Good afternoon, Weber's class. No, McKeever's class. Can you find area and perimeter of rectangles, triangles, and parallelograms?
Yes.
Good, because that's the title. Perimeter and area of rectangles, triangles, and parallelograms. Eyes up here. Perimeter would be the distance. Boom. Area would be the space inside. So perimeter, outside, area. Dimensions would be those things that tell you how big something is, right? So the dimensions of that rectangle would be 4 on the base and 5 on the height, yes? And then formulas, you guys know what formulas are, right? But every time we see a formula, we're like, easy. All I got to do is plug in numbers. What's that word that I just said again? Say that again. Say it with enthusiasm. I love the word plug in because we need to do that. All right, here we go. Base times height tells you the area of what 3 shapes? All right. Area equals base times height, rectangle, square, parallelogram. Another thing for area would be, I need enthusiasm. This formula is disgusting because we don't use it to find the area of a triangle, right? Yeah. We actually use this formula right here to find the area of a triangle. It is base times height divided by 2. Because we know a triangle is half of a square, rectangle, whatever you want to call it, right? When you have labels for area, you use units squared, or you could just use U squared, right? Yeah. Perimeter, the label is units. We good? Yeah. All right, here we go. Find the perimeter and area. Remember, area would be the distance around the outside, right? Yeah. Perimeter of a rectangle would be base times height. Good, moving on. Triangle. Perimeter would be add up this side, add up this side, add up this side, right? Yes. Area would be, what's the formula again? Base times height divided by 2. And so, correct me if I'm wrong, this is the height, right? Yeah. No. Is this the height? No. Is this the height? Is this the height? Yeah. Because it's this dotted line going up, right? Yeah. And then that's the base, yes? Yeah. Okay, cool. We had 8.5, but then we went ahead and we just converted it to 8.5 as a decimal and used our calculator. Is that okay to do? Yes. I'm cool with that. Parallelogram. The height of a parallelogram is always going to be the dotted. Parallelograms are always those, not always, but there's sometimes going to be those slanty things, right? Yeah. So you got to find the dotted line because is this the height of a parallelogram right there? No. Is this the height of a parallelogram? No. It's always going to be, if it's a slanty parallelogram, it's going to be that dotted line, right? Yeah. Sweet. And then we were trying to figure out what x is here, right? Yeah. We knew the area of that shape was 17.92. We know the base was 3.2, right? Yeah. What did we use? Everybody, in the count of 3, what did we use to figure out what x was? Or what do I want you to use on the count of 3? 1, 2, 3. Yes. So you simply just take out your calculator and you start punching in numbers until you figure out the right answer. So I gotta get my calculator, sorry. So 3.2, and we just start guessing, right? Yeah. Not plus, but times. We good with all that? Yes.